Thanks, Kelly. It's kind of a cool thing. What we've been doing this whole series, right? We had the session last month, all about the data center, right? The theme is data center, and this is all about the networking side. We're getting into a little bit of security later on, virtualization in the beginning. I think there's a lot of really cool stuff that's happening here, but today's networking just doesn't meet the needs of a lot of the technologies that we're going through. Chad, would you agree with that?
Oh, absolutely, Dave. I think that, in fact, if we want to kind of put it in context from, our last session and look at third platform, and to your point, what is data center, and it's really that cloud piece, right? If you have something out on an island, then it's not connected to the rest of the world, then you have an island, you have Gilligan's Island, right? So I think that the networking is definitely a critical piece all throughout the themes.
So I think of, when you think of data networking, or you think of data center, obviously the data networking piece is big to that. And there's a lot of pieces that kind of come into this in terms of, what people think of traditional networking, right? So I think of like the OSI model, and I think of the concept of layer 2 and layer 3 and layer 4. And does that still apply in today's, in this next universe? I mean, do IP addresses still exist?
Oh, absolutely they do. Certainly some of the concepts and how you tie it together have been streamlined or minimized and made much simpler, but those OSI model is still alive and well. You'll see when we get a little bit later into it, some of that gets collapsed together, but the same things have to happen, right? You've got to figure a way to get something from the physical layer, be that, a copper wire, a fiber pair, all the way up to, more often you see, stuff transmitted through the air. So, today we're going to talk really primarily around the second and third layer, so the data link layer, which is where things like MPLS probably is what most people are familiar with. Certainly, just straight out layer 2 where you have MAC addresses involved. But, once you get to the network layer is where you really have some complexity, because you have to start telling everyone from the top of the mountain who you are, how to get to you. So it's absolutely in play today. So why don't we take a little bit deeper dive in those layers we talked about, just to provide some framework. As I said, the physical layer is where we really have to start things, and that's, for me, a logical person is kind of helps build the story. And then, we get into data link layer, where we're talking about Ethernet, MAC addresses, and then layer 3 is when, typically is when you get the data network gurus, the engineers, and that understand routers. IP addressing is moving to IPv6, which gives you a bigger address space, but it still does the same types of things.
A lot of times when we think about local area networks, right, LANs versus WANs, we tend to, you start at the LAN and it tends to be a layer 2 concept, right, and everything is going from MAC address to MAC address, and it's only really, when I need to go from one LAN to another LAN that we really need to pay attention to the IP addressing, specifically subnets, right, and routing, and you go to this core infrastructure. But, I think of today's applications, like last month we talked about virtualization and some of the technologies that we can leverage as part of that. Like I think of VMware's vMotion, right, and moving a running virtual machine from potentially one part of the network to a completely different part of the network, yet I have to keep my IP addressing the same. So this idea of kind of an edge and a core really kind of complicates things, right? Especially when you start talking about some of the redundancy options, and the first thing I always think of is spanning tree, and how its sole purpose in life really is to eliminate loops But it's those loops that come from redundant links is what we really we need, and we need to leverage, right?
Oh, yeah. In fact, I'm going to steal a line from someone I greatly respect that appeared in their Tech Weekly. I quote, "It's safe to say everyone hates spanning tree and wants to move on to something else as fast as possible. Spanning tree just doesn't cut it anymore." And I'm going to credit that quote to you, Dave. Can you elaborate?
The question is, do you agree with that, or am I kind of off of my own island?
Yeah, I would say as, someone kind of sitting more in that networking, chair, if you will, absolutely agree with you. It's funny because one of the first things you learn as a junior network engineer is, if you have a problem, particularly with broadcast storms, those types of things, right, where you have just everything going crazy in the network, all the links getting fully utilized, a lot of weird stuff going on, first thing everybody says is go look at spanning tree. If it's on, turn it off. If it's off, turn it on. So, it's not even really a good understanding of how that works. And you know how complex that is when you get down to really understanding how that works. It's complicated. It's inefficient. It's not something that I think anybody puts as, one of the favorite protocols out there. So absolutely agree with your assessment there.
And I couldn't agree more with you about how it's one of the things that very early on you learn about spanning tree, and you kind of get scared to death about it, but you set it and you kind of forget it. And so a lot of data people that I talk to really don't remember how to deal with and manage spanning tree, and to a point where, exactly like you said, something catastrophic happens and you get a broadcast storm, and the scariest thing in life is to walk into a switch room and see every activity light just pinged on. There's no blinking, there's no anything, it's just solid, and nothing's working, and it, as you said, it almost always comes down to something happened with your spanning tree, and it's next to impossible to figure out where to start troubleshooting. And it usually comes from somebody connected a duplicate cable somewhere that didn't have spanning tree turned on, and it gets really ugly really fast. And virtualization of the network, right, VLANs, don't help that. It gets even harder because you have per VLAN spanning tree, and it's just an absolute nightmare.
Yeah, I absolutely agree, and that is an area that just the efficiency. You can look at this picture again, which I repurposed, going to give you some credit on there, but you can see how complex this mesh is, and then when you start having decisions made from one node to the next without understanding what's going on elsewhere, it spins out of control very quickly. And to your point, this is probably the only, walking into a switch room or a data center and seeing all those green lights pegged is probably one of the few times you'll ever not like to see a solid green light, right? It's a frightening proposition.
Well, and I look at that mesh network that you have here, and your first thought is, oh, look at all the great redundancy that you have in there, and boy, there's multiple paths to get your data from one place to another, and then you say, oh, by the way, the vast majority of those can't be used because spanning tree shuts them off.
Indeed.
Chad, there's got to be a better way.
Well, there is, Dave, and I'd like to spend a little time on that, and that's one of the things that we really want to focus on today, is that the network's evolving to solve problems like these. One of the outcomes of having that OSI model is things can develop, and you tend to be able to solve problems at that layer, and they get very complex. So with that said, let's take a look at a better way we can do this. So certainly, I think one of the things you talked about, and there are kind of two prevailing thoughts, right, in terms of how that gets addressed, and we'll talk a little bit about that. But it's to simplify, those Ethernet networks, right? So if we want to go back to, the Clint Eastwood "Good, Bad, and Ugly" reference, Ethernet is good because it does, as you described, it's simplicity for that layer 2 forwarding. It's there, right? Now, certainly you have limitations around VLAN tagging, and gets to be particularly problematic once you get to virtualization. And then the ugly is STP, spanning tree protocol, which you astutely pointed out. One of the
what's interesting about that though, Chad, is layer 2 is really fast, right? When you think of the speed of layer 2 versus layer 3, because layer 3 is higher up that OSI model that you talked about, which means in terms of the packet, you have to dive deeper into the packet, shedding more and more of those outer layers to get, we call that encapsulation, and you have to get deeper into the packet to finally get to layer 3. And so layer 3 is slower than layer 2. Now, granted, technology's gotten so we can do all of those things fast, but layer 3 is still not faster than layer 2, given equal processing.
Yeah, and that's a great point. And I think the other thing is, layer 2 is kind of an autopilot, right? You plug stuff in, it starts doing the broadcasting, and it starts figuring out where all its neighbors are and how to get places. You don't have to go put in routing protocols. You don't have to go define routes of how do I get from here to there. So there's obviously a lot more administrative work, configuration around layer 3 deployment. So wanted to talk a little bit about what have been some alternatives. So MPLS is really probably the predominant layer 2 protocol / technology to kind of be implemented out in the marketplace to move away from the concept of layer 3. It's label switching, right? So you're doing things, to your point, you're not having to kind of unwrap the gift, kind of like the Russian dolls, right, where you can't keep unwrapping till you get to what you want. It's really sped up some things, right, that you kind of have one hop through the network because you're not processing those frames and packets, in the case of layer 3, at each interface as you go through. But, so it's good that it's scalable, and it does have some network virtualization capabilities, but very complex. A lot of protocols, and we'll kind of get into that stack a little bit. And then the ugly is that you have, it's almost like a spin out of control that, okay, now we have to have another protocol to accommodate this particular issue or this feature functionality. So it's kind of gotten to be a very complex, not very elegant solution. So in an effort to provide MPLS-like services without the complexity and leveraging the good in Ethernet and eliminating the bad, I'd like to kind of shift the focus here and talk a little bit about shortest path bridging. You had a good example of kind of what those alternatives are out there, SPB versus Trill, right? You did a good write-up on that. So could you talk a little bit about that and, maybe provide a little context why we're going to talk about SPB as opposed to Trill today?
Well, what I find, when we talk voice, right, a lot of our data center conversations this summer, and this summer's been a great summer for data center, right? Hasn't it, Chad? Really? I mean,
it has.
Good summer series. But I find that traditional data networking people are a little reluctant to make big changes on their network, right? And a lot of times when you start going from a traditional type data network, and we ran into this, right, 10, 15 years ago when voice over IP first started coming out, and all of a sudden we had this real-time communication application put on the data network, and you had to change the way you think about data networking, and you had to, as a minimum, you had to implement QoS. As a minimum, you had to start separating your voice stuff from your PC, your computer stuff, just because of, usually it was a broadcast conversation more than anything else. But you had to change it, and I found that a lot of data networking people were very reluctant to want to change anything because it was working, and they didn't want to disrupt that. And I think it's to your conversation about all of those protocols that are in place. MPLS is just one of them, right? But you have all the, whether you're thinking layer 2 with spanning tree, layer 3 with routing, and then ultimately your goal is to get to that creamy, nuggety goodness, NuGet, I believe, is the the application that we're looking for in that environment. And but the key is we've got to find a way to make it so that you can think of your network holistically and just kind of make those changes. And there's certainly technologies out there, right? And everybody has their different play on it. We're going to talk about software-defined networks and whether that really makes sense, because in a way, software-defined networking is just a Band-Aid, or not even a Band-Aid, but a layer on top of your existing stuff that helps you dynamically control it. But it really even then requires you to start thinking about the protocols that can be externally manipulated easily, whether you're talking APIs, whether you're talking about just the architecture itself that lends itself to a more programmatic way of being flexible. And I apologize because I was in Etherville when you were talking about this, but your whole layer or phase 3 of the data center becomes really critically important. So we're entering that same kind of environment where virtualization has become so popular and so predominant, and leveraging some of the big technologies that come with things like VMware, like vMotion, right, where I want to take an existing virtual machine and move it from point A to point B. Unheard of concepts in the old days, and now it's like, you better be able to do it because that's what the hypervisor is expecting you to be able to do. And it doesn't work when you start thinking routing and switching and setting up VLANs and statically programming things to happen. And okay, it's working. For the love of God, don't touch it anymore. You have to be flexible with it, and the traditional protocols just don't lend itself that way.
Yep, you're absolutely right. So if we're going to look, and we'll explore those. Not only SDN, but the NFV, the Network Function Virtualization, a little bit later, and how does that all tie together? So I think you really set the stage there. One of the key points you put is that a lot of these evolutions are built around the virtualization wave, right? So you want to simplify things because as you move things logically around, you can't take all those sets of rules everywhere you go and transport them very easily and move them into those devices. So you tend to kind of centralize, in the case of SDN, centralize the control plane, those types of things. So it all really ties together. In the case of SPV, fabric, this is really a rethinking, as we talked about on the last slide, kind of a breakout of the traditional rule. The whole fabric is viewed as a single switch, so it means it's truly at layer 2. You're not kind of patching this stuff together on top of it to make it look like layer 2. So obviously that makes your network easier to design and operate because you don't have to, figure out, okay, do I have all the VLANs on the right interfaces, those types of things. It makes it really easy to segment devices and users, and the convergence is much quicker. So if you have failover, those types of things, it happens a lot quicker. You don't have to converge, BGP routes and all that stuff that has to be advertised and communicated out, and your RIP and all those routing protocols that are very heavy in terms of demand on the processor don't have to take place. And then lastly, it is agnostic from a topology perspective, full mesh, partial and loop. So as you talked about, why spanning tree protocol exists because of 2 links between 2 devices, same kind of principles apply to SPP. That is a violation, but the difference is if you break that rule, the second connected link becomes inactive, and it's a backup link that you have failover. Your failover is still sub-second. So you are automatically or inherently solving that problem that you were trying to establish multiple paths. So I think that's interesting.
Well, and you talk about the speed of failover. I mean, traditional spanning tree is 50 seconds. 50. Even if you were to go with rapid spanning tree or fast start spanning tree, that's still like 6 seconds. Well, when you're an email or a web page, who cares if you have a 6-second delay as the spanning tree process identifies its new root bridge, right, and figures out the root ports and the bridge ports. But in the world of voice, you drop entire phone calls in that amount of time if packets don't get there. So gateways could potentially reboot. I mean, there's a lot of things that happen within 50 seconds. My gosh,
that's a long
so I
time.
love the idea of sub-second. It might be a little blip that you hear, but I would guess it's such a sub-second. I mean, we're talking milliseconds typically. Those are you'll never notice that.
That's right, and particularly important, as you pointed out, in a real-time application such as voice. So, we've talked about the complexity, right? So I thought this next picture really kind of shows, and the title's kind of, tongue-in-cheek a bit, Rome wasn't built in a day, and neither was the network. So, as we talked about, if you look on the left side here, the protocol stack is very complex, right? And it starts and it grows over time because we didn't think of this. We have new applications. We have new need to do, like in the case of PIM, you want to multicast. You want to do one-to-many, many-to-many, those types of things. And those just kind of get stacked on top. So this gives you a really good feel for kind of how, built within the constructs of the OSI model, so it all works together and you can, change things and all that, but very complex. And, obviously when you have things go wrong, you have to coordinate a lot of things, whereas if you look at the picture on the right, where really you have Ethernet, and then at the top you have your operational, administrative, and maintenance tied in, everything in between is taken care of by SPB. It's a single protocol. That really drives home the difference in what we're talking about in designing, deploying, and managing a network. Which one would you rather, job security aside, which one would you rather manage, the left or the right?
Yeah, well, like I said, the left is it literally is that house of cards. So if Rome wasn't necessarily a house of cards, but you find yourself just being debilitatingly overwhelmed with the complexity, and you could say, well, that's what people's jobs are, and people's jobs are to make sure everything's running right and consistently running, so you don't have the GoToMeeting issues we had this morning, right? Somebody's not doing their job.
Right.
But you have to have the flexibility for these new technologies. And, the standard 802.1AQ that is known as shortest path bridging is absolutely a simplistic way to view it. What I like about a lot of this stuff is it really kind of flips the idea of layer 2 and layer 3 together, right? Because everybody's first concern is, oh my God, does that mean I have to rip out everything that I'm doing today and swap everything out to shortest path bridging, and do all these devices understand that? Because at first glance, it almost looks like, well, does IP address go away? No, IP addressing still exists, right? MAC addresses and Ethernet still exist, but the difference is you start administering these ports and these services out at the edge, and you just don't care about how it's happening in the core of it, because it's the protocol itself is doing all of that communication and configuration.
Yeah, and that's interesting. I think you kind of really put an interesting insight on that if you consider the way that things have traditionally been done, kind of core out, right? You've got to allocate your address space, all that, and then you've got to propagate all of that all the way out to the furthest edge of whatever device you're going to add. It's almost an inversion where you don't worry so much about, or really don't worry at all in terms of the core, and your VLANs, all that stuff kind of sits on the outside, and then it's seamlessly kind of tied together through the core. That's a huge difference in the way we've approached things.
Yeah, well, like you said, the core is usually, we think of the core as being the wide area network, the WAN, and WAN is always associated with layer 3. It's always associated with IP addresses and subnets, and that's where routing takes place. And so the core tends to route, and the edge tends to switch, using Ethernet. And this literally flips that around, where I'm doing layer 2 everywhere, and then it's only, I think of layer 3 at the edge, which is a kind of a mind-blowing concept, but it just keeps that consistency of doing things the way, thinking of it maybe the way we've done it before, where, okay, I still have like IP phones and PCs, and they get an IP address. The difference is once it hits the Ethernet switch, we kind of think of everything else from layer 2 then on and get it to where it needs to go. So I like that one slide that says, now for the first time we can think of the entire fabric as being an Ethernet switch. And that's just, it's mind-blowing.
It really is, and it kind of makes you wonder why did it take us so long to get here, but we do understand Rome wasn't built in a day, and networks evolved over time out of need, and necessity is the mother of invention. I probably have 10,000 more colloquials I could throw, but this is really, and I'd like to, maybe we can bring this even further into view and look at, traditional MPLS versus SPB, right? This talks and this shows your observation about, MPLS, traditionally you've got kind of layer 2 out the edges, and then you're really packet switching, but, look at the reality, right? You've got, you certainly still have, the 802.1d and Q, the STP. You've got all these things kind of still in play in the background all the way up through the MPLS layers. So you have, you have routing protocols like RIP and OSPF, you have PIM, you have VPLS, you have all of these things going on that are, swept under the rug or hidden behind the scenes that still have to be maintained, still have to be configured, designed, and administered, just to offer a layer 2 service. And look at the simplicity of SPB on the right. I mean, it's all in that protocol. There's nothing else to manage. So this, to me, really reduces or pictorially kind of puts everything you just described, in one tidy package.
Agreed.
So, just delving a little more into SPB, right? We're going to, we've talked about it. It's fast because you provision at the edge. You don't have, you don't have configuration at every interface. You don't have to define VLANs and sub-interfaces, those kinds of things. You have optimized link state protocol, and the conversion healing is much faster. Flexibility is, far exceeds what we have in our traditional architectures. And really what that allows you is to take advantage of kind of the virtualization. And then security is a big thing. We'll get into that in some more detail, but it really isolates the service, and you get, zero complexity in virtualization, and the network is truly invisible to users. So those are a lot of the reasons that SPB makes more and more sense, because virtualization is becoming more and more prevalent, and it really supports that in a much better fashion than we have traditionally, and it does provide really almost more what you'd consider plug and play. Once you configure your edge device and get it plugged in, then it kind of natively moves through the network to get to the other communication points. So if we look at the simplicity, this picture says a lot. You look at the left is the status quo, right is Fabric Connect. If you're going to consider all of these devices that are connected, and each of them has an interface, and each of them you're going to have, sub-interfaces, VLANs, routing protocols, route advertisements, all those things to kind of keep it in sync. That's a lot of care and feeding. On the right, you've got an automated core, which is zero touch. I mean, you can't beat it in terms of simplicity.
So when I think of some of the edge only, comment you made of that the core is invisible to the user, to the edge, because again, it's kind of, you don't see all the intricacies of you don't see router hops, you don't see a lot of that stuff. That has to be a big security play. right? I mean, because one of the first things you do as a hacker, not that I would know, I don't play the role of a hacker anywhere, but you start investigating and you find out okay, where are the things, what's going on, and once you can identify core pieces, then you can understand the underlying architecture, and again, that's kind of step one, is to figure out what's there and how things are set up so you can identify vulnerabilities. I mean, can we dive a little deeper into that security conversation with this?
Would love to. I think your point, your first point is that you're not exposing all of this out to the outside world. So you really eliminate vulnerabilities to a large extent because the fabric is invisible. So there's not, hop by hop routing, so they can't probe and say, let's go out and put a port scanner on it, see who responds. I mean, you know the story. You're going to put your port scanner on. You're going to scan a subnet. You may have 99 of the interfaces locked down. One of them you forgot, and it makes itself known to the outside world. And that provides the bad guys an avenue in. Then they can start pounding on it, and they get in, and once they're into your network, then they have the same paths available to them that they would, that anything flowing through your network would. So that one is very important to understand, because that really is not possible in the fabric environment. And then your network segmentation. A lot of when we talk about if you look at NSX, which is the network virtualization piece for VMware, it's all about micro-segmentation. How do you compartmentalize things and don't expose them? So everything is really happens within the context of the layer 2 or a specific layer 3 VSN. So users, their communications are shielded to a large extent from the fabric, from any intrusion there. So it really is, instead of it's a lot like we talked about before. It's kind of flipping the model on its head. You really go from where in the traditional architecture you have to go lock down everything, and really in the fabric you would have to explicitly expose things. So it's a different philosophy. It's not like, oh, did I go check all my doors? Your doors are automatically locked, and you have to unlock them to allow people in. So it's a different philosophy. So it really supports that simplicity. The security is just an inherent part of it. Certainly not unintended, but it's definitely part and parcel. And one of the things that's going to be more important as you have more devices connected to the network, a la IoT, and everything becomes more. Look at all the smart devices. Look at how, to log into any access point or wireless router, and you'll see how many devices are connected. All of that is at the edge. So really, you're going to have. We'll talk about security in the next session, but those are important areas to lock down. But for the most part, you're in a fabric environment. Your environment's secure to those endpoints.
So you raise a really, really, really good point with the Internet of Things and knowing, just the nature of those things. I mean, obviously, the IoT describes just this overall level of connectedness, that everything is talking to everything else. But a lot of the things that they're talking to, or what they are little, they're components, they're sensors. And when I think of security, obviously you have to your point, we'll talk about this next month in our third part of the series, where security is a multi-layered approach, right? You not only need infrastructure level security with the network, but you still firewalls and application-based security and encrypted traffic. Those things don't go away, but you have to do all of them. And today, really, the only network level security that we have is 802.1x, right? Where you're authenticating almost to the Ethernet switch itself to get your link light. And I'm like, well, okay, now you have to log in. So you're telling me with IoT, you're going to have to log into your sensor to get your sensor to talk to your thermostat, to talk to your furnace, to talk to your whatever. And there's some inherent usability problems with that. And all of a sudden it kind of points back to the fact that, okay, well, we may have to put way more emphasis on endpoint security, endpoint network security than we have in the past. And like I said, most customers that I talk to are not doing 802.1x. Some of the high, the big, maybe financial firms are looking at it and, locking down individual ports, Ethernet ports on the switch, but the vast majority of them aren't, and it usually comes down to the complexity associated with it, whether it's certificate-based or whatever, and people are like, let's go rely on application-based security, and you find out very quickly that you need all of it, right?
Yeah, you're absolutely right, and that, I've read, I'm not going to call them horror stories, but real-life examples of Internet of Things in action where somebody goes out and they say, hey, look how cool this is, and within, 7 milliseconds somebody's hacked into it because they didn't change their default password, right? It's admin, whatever, right? Those kinds of things, to your point, locking down that endpoint is the more and more the focus, and this is a good thing because as you batten down the hatches and start to really secure the network infrastructure core all the way out to where the endpoint connects, then those are areas you don't have to worry about. So you can dedicate more focus to locking down the endpoint because, let's be honest, if you have, it can be very overwhelming, from a security standpoint of all the potential vulnerable spots, and if we can take a lot of those out of play and improve performance, decrease complexity, increase simplicity, drive easier management administration, I mean, what's the downside, right? We live in a very complex world, and whenever we can simplify that, we should do it. So this is really, it's a very pointed conversation, but it is relevant to really where everything's going, and our discussion along kind of the third platform as a driver.
So Chad, let's shift gears just a little bit, and when I think of, you mentioned virtualization and how important it is, and my first thought when I hear virtualization is, again, I go to the hypervisors. I go to the VMware that is setting up a virtual machine. So like in the Avaya space, all of the current servers and services can be virtualized, and I could literally, not that I'd want to, but I could literally move a running server from point A to point B, whether it's in the same rack, in a different rack, or even a different building, and move the server by right-clicking on it and say, hey, now go over there. And I think, we talked about how SPB is so critical to support those kind of things, because now in the old days, I would have said data center 1 has this set of IP addresses, right, because it's a location, it's a subnet. Data center 2 is across the country, it's on a different subnet. Well, how am I going to move a virtual machine from data center 1 to data center 2 if they're different IP addresses? Because I'll have to re-IP address the server, and you can see where, well, vMotion's not going to work. That's not going to do anything. And so SPB is one of those things that says, okay, by the way, that same exact subnet now exists over on port number 38 in data center 2. So again, I think I get the concept of how that works from a virtualization of the virtual machine. But when you talk data networking, there's the whole topic of virtualizing the Ethernet switches, and that's it's kind of mind-blowing to me, and it's really, I have found it hard to wrap my head around, because then I hear terms like SDN, software-defined networking, and I hear these terms of NFV, and all the, the network virtualization stuff. And now all of a sudden I'm trying to like, okay, what are the what's what, and are they relevant to the traditional virtualization that I think of with VMware, and are they relevant with shortest path bridging?
Well, that's a great question, Dave, and I think that, in a lot of people's minds, they see these as all alternatives to one another, right? I mean, certainly SPB is part of the SDN strategy, right? It's a piece of it. The NFV, the Network Function Virtualization you talked about, is the virtualization of network along what we've done with compute and really what we talked about in the last session, and NSX being kind of the, probably the flagship product out there in the market that VMware hangs their hat on. So maybe if we talk a little bit about SDN and NFV, what are they, and compare and contrast, because it's all complementary and they all kind of play together in the same sandbox, so to speak, but they're different and have different objectives and different capabilities. So I like to think of SDN as, I'm an old, ultimately at heart, I grew up in central offices and all that, and, the out-of-band signaling, the common channel signaling, right? You remember SS7 and, even PRI, that kind of stuff, right?
Right,
so
the D channel, yeah.
It's analogous in some respect to that, but SDN breaks apart the control and the data. So the payload is going to go down a different path than the control packets. And the reason that we do that is so that, we're simplifying, again, the control and programmability of the network. So if all of the devices that are out there doing the physical switching or routing of the data through the network take centralized instructions, then it gives you some additional capabilities, because when you pair orchestration with that, and this is really where SPB comes in, right? Once you pair orchestration with that, you can dynamically react, or in some cases be proactive in changing conditions in the network. Whereas used to we depended on calculations made of, what is the, the OSPF, or all those kinds of things where we had to manually calculate and say, well, what is the weight or the cost of getting this piece of information, this packet, from this point A to point B, and that changes all the time. Well, that loads you down from a processing perspective. So really, this centralization that SDN does, and primarily in campuses and data center and cloud, is really kind of moving the needle along to say, give us additional capabilities. OpenFlow, I think you've heard that protocol. That's prevalent in SDN, and this is really the goal of SDN. It's to enable orchestration, enable simplicity, but really is starting to break apart the structure of how we do things to give you additional capabilities. Now, to your point earlier, NFV is different. It's virtualization, so it's taking it where you see the applications for SDN more around cloud orchestration and networking. You're talking about routing, firewall, gateway, content delivery, WAN accelerators. All those things are network elements. We've certainly gone beyond routing and switching, but it's virtualizing those so that you can take advantage of resiliency, redundancy, all those types of things, and putting that feature functionality where it's best used. So instead of backhauling and connecting a lot of different devices via, IP bandwidth to a firewall, that firewall functionality can live where it needs to be, so you reduce your bandwidth consumption, the time to get through, it is a much more efficient model. So, and it's an ETSI, it's in an ETSI working group, so, certainly well on its way to being established as a ratified kind of de facto course forward. So, putting SPB with SDN and NFV gives you kind of the holistic view of it. Does that help kind of frame up the context?
Yeah, so when I think of SDN, really SDN is a controller. Let's call it a box, let's call it a server, and it is dynamically changing the configuration of existing Ethernet switches, routers, firewalls, maybe changing VLANs. So instead of an administrator going in and making those changes, some controller is doing that. And maybe it's for, I don't know, making the user interface easier. Maybe it's for, like you said, making dynamic decisions of, hey, and this might sound like a weird analogy, but I just had to replace my furnace, right, and my air conditioner, and I had to make a decision of do I want to go with a heat pump, and a heat pump is kind of an air conditioner unit that reverses the air conditioning concept and uses electricity to generate heat, and the thing that I quickly learned about this is, well, it depends on what do you pay for your different sources of fuel, right? Like in Minnesota, we get natural gas pretty cheap, and electricity is more expensive. So I don't want to use electricity to heat my house. I want to use natural gas. Well, all of a sudden they're like, oh, well, the controller, the thermostat is smart enough to switch back and forth between electricity and natural gas depending on what the price of those fuels are. And my first question was, well, how does it know what the price of the fuel is? They said, well, you have to program it in. Like, well, that changes all the time. And, I mean, wouldn't it be great? Duh. Why wouldn't it's already connected to the internet. It tells me what the weather is on my thermostat. Why couldn't it go to my electric company and find out what the current rate is that I'm paying in electricity, and same way with gas, and then dynamically make an adjustment to say, oh, actually, right now, it's better to use electricity to heat your house and not gas. That, to me, sounds like a SDN controller controlling existing things, making dynamic decisions without me having to get in the middle of it.
Your analogy is great. It actually incorporates the orchestration piece, right? You've got something out there orchestrating to say, I'm going to do some processing, analyzing why we should make the decisions, and then I'm going to give it to you as the controller, and then you go out and execute on it. I think that you really, that's a great analogy you used, and it's very, very relevant to kind of the role of SDN in the world today.
Well, and I got really good at understanding heating and cooling as part of this process. He needs advice on cubic feet per minute. And I'm a geek, Chad. When I go geek, I geek out on anything, even if it's heating and cooling. But I think maybe more relevant to us in the communication world, even system manager, right? The Avaya or a system manager has an API exposed to it that allows you to programmatically, externally programmatically, change SIP routes, so like think of your call routing and your ARS, right? Well, in System Manager, I can program my session managers to make decisions about, okay, well, when do I want to use this SIP trunk? When do I want to use that SIP trunk? And generally, it's static. But because Avaya's exposed that API, I could have some other orchestration component make decisions about, oh, hey, based on what's going on right now, for whatever reason, I'm going to programmatically change your route patterns to something different. That is cool as hell, right? That's,
it really is.
Pretty awesome. So again, maybe, we talk about, okay, SDN is this controller. NFV is really taking my existing stuff like switches, routers, firewalls, and instead of buying them as a box with a whole bunch of ports on them, I could almost buy it as a server, like an off-the-shelf server, or in VMware, and start virtualizing those things. Again, I think there's an obvious connection to shortest path bridging, right, because of the dynamic nature of that. Am I thinking that right? Or, I mean, do these three components really fit well together?
Yeah, they do. In fact, if you want to look at a Venn diagram here, you'll see how kind of there's overlap, right, between the roles, and certainly shortest path bridging, if you want to look at it as a simplification of the role that the from two angles, really. It makes SDN's job and the orchestration piece easier because you don't have as many touch points to manage and all that stuff, and you do have, you do kind of have that open loop back from a orchestration piece. So that really spurs some kind of innovation where you can start to look at and bring in some third-party applications and stuff, and you have a lot more latitude in terms of how you bring them in, because you are going more to kind of common servers and switches and white box stuff instead of having specific appliances and all that. So it fits very nicely together in this relationship with SDN and NFV.
So the big question is, who's doing it? Are we seeing customers that start out in a traditional layer 2, layer 3 subnetting and environment?
We are absolutely, and I'm going to give very little treatment here because this is the same theme we talked about before and after. And I've got an example, a couple of drawings here that I'm going to show. But before it's complex, you got multiple protocols. You've got, and I can say just from a BGP perspective, if you have 2 data centers up and you're running multiple service provider carriers in there, and you have to advertise BGP routes out all over the place, you have another carrier connecting the 2 data centers directly together, so you have routes out to the internet, you have routes between devices and all that. It gets to be very complex, very cumbersome, very fast, and not an efficient use of resources. You have ports and links and bandwidth that sits there waiting for something in case something bad happens. Your recovery, your convergence times are very long, very slow. And then you go to a Fabric Connect SPB configuration architecture, then you're back to one protocol, and that fabric is one single switch out to where you connect in. So moves, adds, and change, your endpoints, you put them on. You don't have to say, okay, I'm going to put that on. Oh, that's on a different VLAN here. Let me make sure we have this VLAN configured on all the interfaces in this, each hop all the way through. Load balancing, and again, the recovery is sub-second. So it's really a night and day example. So with one of our customers, want to show you their traditional architecture where you have data center 1 and 2, you have cloud, 2 different clouds kind of connecting it out, and you have them connecting through to different servers, devices in the data center. You have them out to the main office, DR sites and all that. And the important thing here is you look at all these endpoints from a data networking. All these devices in there have to, in this architecture, have to have context around, how they make themselves known to the rest of the world. They've got to advertise routes, they've got to receive routes from others and all that, and that means you have to configure each of these, you have to manage them, you have to change them when stuff changes. Very complex, and this doesn't begin to, originally I had a lot of the BG and all that up there, and it was just too ugly to even try and describe. So,
well, I was going to comment on that. Of the version of this that I saw, it had a heck of a lot more border gateway protocol stuff going on with BGP. Anyone who's done that knows what a nightmare that is to program and maintain and keep it consistent throughout the network.
Yeah,
so
but I mean,
you've almost simplified it too much on this before slide. But I know how ugly this was.
Yeah, it is a little bit, but to your point, if you've got to advertise your AS number and your routes out to both carriers from both of those, the core switches there, and everything in there has to understand it. Anything touching anything has to understand through these routing protocols and border gateway protocols and all that what it looks like. So it's very ugly, and I just I kind of debated whether to keep it really ugly and not really be able to point out anything specifically, and then we go to Fabric Extend where we're SPB. look, we don't, this is a connection into and through those service provider networks, and we're extending that fabric out to the customer premise at the main office, out to any of their DR, anywhere we go and we place a fabric-enabled device out there, that's where the fabric gets extended to. So you're taking all of those things, all the routing protocols, you're taking all those advertisements, all those subnets and VLANs, they get taken out of play. So literally you could have a fabric that spans coast to coast, multiple offices and all that. It all looks like a single switch, which is a beautiful thing because it inherently, intuitively knows how to get from one to the other without doing a lot of advertising, calculating which is the best path and all that. That's all done intuitively. So it's a huge difference in terms of time to deploy, design, implementation effort, and then management. And then as you do moves, adds, and change, it's really no touch core. It just works. It's
well, so an interesting point that I guess that brings up is, again, most of our big customers, they're going through crazy amounts of mergers and acquisitions, right? That's just the name of the game. In today's world, when you're growing your business, you either grow it organically or you buy somebody, and all of a sudden it looks like you grew. And when it comes to any public company, they are trying to show growth any way they can. And so, again, point being is mergers and acquisitions are a big deal. And I don't know about you, but I've been involved in some of our own internal mergers and acquisitions, and I can tell you that nowhere on the little checklist of hey, should I acquire this company or not, is anything that says, hey, how is their network, right?
Oh,
so
right.
It's usually the IT department that gets stuck and the telecom team that gets stuck at the end saying, oh my God, we just acquired this company, one of the first things you have to do is we got to get these networks up and running. And talking to each other on the same system, and it's rarely a case where you can rip out all of the infrastructure that is in that new acquired location. But with this, I can say, well, all I have to do is replace, maybe their edge, and they can keep everything on their prem. And now that fabric, it extends at least to the location. Yes, they're going to still have to do some of the typical traditional administration that they do on their legacy network, but it buys you a ton of time and gets them on board, gets them with the simplistic programming and administration, and then buys you the time to say, okay, what are we going to do? Are we going to keep their existing legacy network in place? Are we going to replace it and push that fabric literally all the way to the edge, or at least just to the entrance of that location? But it gives you a ton of capability that you would never have before. And I think it makes a good point of how seamless shortest path bridging can work with an existing legacy infrastructure. It doesn't have to be a full rip and replace right off the bat.
Yep, and that's a great point. You extend it to whatever's practical, and then as it makes sense, you can extend it out, and it's very easy because it's just dropping a fabric-enabled device in there, and it connects back into the rest of the fabric, and you're good to go. Just anecdotally, I wanted to share this. We did have a workshop a year or so back on SPB fabric, and we had 6 different teams, and they had their own switches and all this, and we were going through and learning all the new terminology and all that stuff, and we one of the first exercises we had to do was, okay, let's stand them up and let's talk to everybody else. And literally within 10 minutes, all 6 teams had their fabric switches up, had fabric connected to everyone. It was up and fully meshed and working. I mean, literally in 10 minutes. Just blew my mind when that would have been something of, you normally would have had to really do a lot of planning and a lot of things. You could almost do it within a vacuum to say, okay, here's how it sets up, and then the fabric extended itself across to all these different nodes, which theoretically sat in different offices or different data centers, and you're connected and you have, path through. We could pull a cable on this side and it would automatically go back through the other path, and it was just amazing. So I think your point there is well taken. We definitely are entering a kind of a new age to where you don't have to, you can kind of maintain what you want within your existing legacy environment, and you can plug it into Fabric, and Fabric will do the job that it does. So very exciting, and again, you kind of go back and forth as a data networking professional, say, is this a good thing or a bad thing? Well, it's a good thing, right? Because you want, you don't ever want to have artificial value. This allows you to kind of, now we can start thinking about other things that are important to drive additional value, like, okay, let's look at how this would work with NFV and with SDN, and having a more holistic solution. So it does free our hands from having to deal with the routine stuff that, quite honestly, is is an administrative nightmare at times, and focus on the real important things that are going to matter to the end users.
So Jed, last month we did virtualization. This month we're doing networking, right? All in context of the next generation data center. And next month we're doing security. You want to give us a real quick sneak preview of the kind of things we're going to talk about in the next session?
Sure, I'd love to do that. So, next session, I think a lot of, and we touched a little bit on that in our conversation, but security is a broad topic, right? I mean, I think in most people's minds, they think of security being, okay, it's a firewall, it's, it's going to be all about, keeping bad guys out, and, and kind of protecting data, but it's not just intrusion detection, intrusion prevention. There's unified threat management, there's kind of behavioral analysis. There's a whole host of different ways that that security is provided in an IT environment today, which is, let's face it, voice is still the killer app in an IT environment, right? It's largely just moved to kind of that application status, so that's kind of how we want to address it. And then, we'll talk about, as we get out from, kind of what you do in the core, what's important, you can do, web filtering, application control, all these kind of neat things, and there's a host of different suppliers or OEMs out there that do some really cool stuff, all the way out to the endpoints. And, IoT is going to be more and more important. How do you protect those endpoints? How do you really manage that holistically? So it'll be a really interesting, I think, insight into kind of security. Something that I would say, security, you could ask 10 different people what it means, and they're going to give you 10 different definitions, and they're all right? There's aspects around social engineering and all that, which we'll probably touch on lightly, but we're really going to buckle down on the network security piece of it, and give it a good insight there. So I'm looking forward to it, and I look at security as the wrapper, right? We've got infrastructure being compute, storage, networking, and then you have applications that live in that environment, and then security is the wrapper that puts the blanket around it and makes it all safe. So that's kind of where we'll go.
I think that sounds fun enough where I think I'm going to attend that one.
Well, I hope you do.
So with that, I'm going to pass it back to Kelly. Kelly, do you have any closing comments?
Yeah, no, I just want to reiterate again, thank you for hanging the line. We did have some GoToWebinar issues. I think there was a complete blackout, so I apologize for that. We, again, will be hosting another webinar next month to kind of wrap up the series. That is all we have for today, so thank you again for hanging with us, and have a great day.